Sewage treatment plant is one of the main sources of carbon emission in Malaysia. Carbon is emitted in three major ways in the sewage treatment plant, which are electricity generation from non-renewable resources, such as fossil fuel and natural gas, are burned to generate electricity for all the equipment in the plant. Next, flow sludge processing, where sludge is transported to be used as fertilizer. And lastly is the energy wastage in the oxidation stage, where high power motors operate at their maximum capacity regardless of the volume of wastewater, and all of this contributes to carbon emission. This is where our solution comes into play. We are the H2Optimizer, and in our team we have Jocelyn, Jingying, Wei Ling, me myself, Li Tong, and Lin Yong. We are electrical electronics engineering and computer engineering students from Malaysia. The sewage treatment plant that we are discussing here is located at Kuala Sawah, Negeri Sembilan, Malaysia. Here are some of the information related to the operation of this plant. And this is the sewage treatment plant from Google Maps, and the wastewater treatment process in this plant is shown here.
First, we are proposing to have floating solar plants laying on the water surface of the reservoir. This is because the dam has a large surface area suitable for floating solar plants. With that, deforestation can be avoided while maintaining the trees as carbon sinks. Floating solar plants also shade the water from sunlight, which reduces algae bloom that produces methane gas. Thus, greenhouse gas emissions are reduced by using the floating solar plants. The solar panel chosen is the Sunkeco SAM 410 watt HC monocrystalline silicon solar panel. Through calculations, we have determined that 3,744 solar panels and an inverter with a size of 300.58 kilowatt are required to supply electricity fully to the plant. Next, each reservoir will hold up to 24 multiplied with 40 solar panels. Next, to extract maximum power from the solar panels under varying weather conditions, a technique known as maximum power point tracking (MPPT) using machine learning algorithm has been employed. MPPT is the point of current versus voltage trend when the trend of power versus voltage is at its peak. The figure in the right shows the machine learning model simulated in the MATLAB.
The second solution is using thermochemical method to process the sludge and generate electricity from the output of the treatment process. This method was used in sludge processing to significantly reduce the sludge solids content. Anaerobic digestion process is a thermochemical process where anaerobic bacteria is used to break down the organic matter in sludge in the absence of oxygen. The anaerobic digestion output is biogas and digestate. After the process, the biogas was further purified by water scrubbing. The purified biogas can serve as a green source energy by replacing fossil fuels in supplying the generated electricity to the wastewater treatment plant. Hence, the emission of carbon dioxide due to the burning of fossil fuels can be reduced to a lower extent.
Besides, this proposed solution is aimed to reduce transportation costs and the carbon emission due to transportation of waste too. As after anaerobic digestion and water scrubbing, not only the carbon dioxide and hydrogen sulfide were removed, but also reduces the volume of sludge by 40 to 70%. The net calorific value of biogas in Malaysia is between the range of 16 to 28 megajoule per meter cube. Assume that the electrical conversion efficiency of a power plant is around 35% and the daily biogas produced is 2,500 meter cube. The range of electricity generated from anaerobic digestion is in between 3,850 to 6,800 kilowatt hour.
Lastly, we have the aeration monitoring system as our third solution. Dissolved oxygen play an important role in providing a good environment for the microbes to break down wastewater contaminants such as organics or ammonia. With that, it is important for us to closely monitor the dissolved oxygen concentration during the treatment. In this solution, we propose a fit-for-a system where we have identified the surrounding temperature as the key disturbance. This is because temperature has a great impact towards the solubility of dissolved oxygen. With temperature sensor as our fit-for-a controller, we could quickly adjust the water pump prior to the actual decrease of the DO in the water. To implement this strategy, four main components are involved, which are temperature sensor, dissolved oxygen sensor, programmable logic controller, and lastly, the variable frequency drive. In the fit-for-a system, the DO sensor would act as a primary feedback loop of the system to monitor the DO level in the wastewater, followed by a temperature sensor that is used as a fit-for-a control system to provide early warning to the PLC. With this implementation, the energy could be saved at the same time reducing the overall OPEX since the oxygen will be only supplied upon demand. Overall, the project would take approximately $5.35 million. To ensure the project could be carried out swiftly, we have targeted three potential sources of funds, which are government grant, solar panel adoption plan, and lastly, the tourist attraction.
All of the solutions will be implemented as shown. The floating solar plants with machine learning-based MPPT algorithm generates DC output and is fed into this inverter to convert the DC to AC. The sludge processing generates biogas to be combusted to turn a turbine which generates AC output, and this AC output is combined with the AC output from the inverter. The electricity generated is used by the plant itself, and it is also fed into a smart grid. By having this configuration, when there is excess electricity generated, it can be sold to the electric utility company, which is Tenaga Nasional Berhad in Malaysia. And when the electricity is not enough to support the operation of plants, it will draw electricity from the grid, which the electricity is purchased from Tenaga Nasional Berhad. And with all these solutions implemented, up to 1,386.4 tons of carbon dioxide can be reduced per year, and $158,000, which is about 67% of the operating expenses, would also be saved per year. And this surely brings a big impact to the community. And with that, we are ready to produce cleaner water in a cooler earth. Thank you.